Jackie. I'll start my presentation and I'm going to go fairly quickly through it, so I'm hoping I can do some demonstration towards the end. So Jackie's already mentioned about me, but I'll just add to that. I'm a TPG recipient. I'm very grateful to be attending this conference here at FOSS4G. So to start with, I'm going to introduce NetCDF, CF or Climate and Forecasting Conventions, and THREDDS, what a THREDDS server is. And one of the APIs that THREDDS service provides, a subsetting service. I'm going to look at that one as well. So NetCDF, it's a well-established binary data file format for representing gridded data across several dimensions, such as spatial, variable, and temporal dimensions. And these are self-describing data files that are widely used in the scientific community. So climate and forecasting conventions are a set of conventions that go on top of NetCDF that describe some conventions for internal structure, and these conventions further enhance the self-describing nature of earth science, weather, climate, NetCDF data, and it makes programmatic extraction of that data easier. So THREDDS, Thematic Real-Time Environmental Distributed Data Services. It's a well-established network service. It's a web server for delivering gridded data sets through various scientific services and APIs. It also provides metadata and queryable interfaces, and it's been around for quite a while. So the THREDDS NetCDF subsetting service is one of those web services available from THREDDS, and it provides a timely, scalable slice and dice of NetCDF data over various dimensions like spatial, lat long, time slice, and the variables of the data set. And it allows for download in CF conventions and the classic NetCDF 3 format. I'll just come back to those ones a bit later. So I have a question here. Let's question some of our assumptions. Who remembers maps before Google Maps? So we're not talking paper maps. I am showing my age here, but Google Maps was a fantastic innovation. It achieved excellent response times by pre-rendering a set of features or layers, and it sort of introduced the concept of slippy maps and really popularised the concept of tiling. And users were okay with the stale pre-rendered data, all because of the incredible response time. So before slippy maps, maps were generally rendered based on the user viewport of the map. And as a result, the maps before Google Maps had absolutely atrocious response times. They were like 30 to 60 seconds to render a map. And the reasons behind that, there was expensive operations going on. There was a viewport bounding box query of the spatial extent. There was simplifying the data, reprojecting it, and rendering it. And so in light of tiling, traditional bounding box queries for maps became considered to be unscalable. So this was sort of a precedent that's been set in the GIS web ecosystem. So let's take a look at NetCDF and THREDDS. Specifically, let's look at NetCDF subsetting service. And NetCDF data is dimensional data that can be efficiently sliced and diced. So what about our bounding box query? Well, as a dimensional structure, our NetCDF files can be efficiently sliced and diced over latitudes and longitudes based on the subsetting service that's available. So we have efficient bounding box queries. So what about simplification? The NetCDF subsetting service provides a Harris stride parameter, and this allows us to decimate our responses of the gridded data. So we can, by looking at the map extent and the spatial extent of the data set, we can come up with a horizontal stride that will give us a constant pixel dimension. So what about reprojection? So most modern mapping libraries allow projection to be done client-side, but then let's not avoid burning the client's CPU unnecessarily, because NetCDF files may share identical grid latitudes and longitudes for different time slices, or for even different NetCDF files if they're related. So let's keep a client-side projection cache, so for any lat and long that we do reproject, let's not reproject it a second time. So when we put this all together, we might want to reconsider our prior assumptions of how the GIS ecosystem has evolved. That's regarding NetCDF data, of course. So tiling and its related caching derivatives is now ubiquitous, and maybe partly because of our prior assumptions, we've come down this track. The THREDDS NetCDF subsetting service and the OpenDAP service, which is another similar service, they might let us re-examine our assumptions. So 20 years down the track, we may be basing our assumptions on some principles that have changed. So what's changed in 25 years? Now we have fast networks and we have high compute end devices like mobile phones. So the modern smartphone and modern networks might allow us to re-examine our prior assumptions, because the relative compute power of a smartphone versus the screen size is just awesome today. And now today, users expect live data, not cached data, also served with the great response times. So going forward, I believe THREDDS will continue to enable us to explore new and contemporary solutions. So my work to date in this area, I've done 2 repos. The first repo is called CF Render, and this is a NetCDF CF rendering toolkit. So this is a JavaScript toolkit that can take a NetCDF file and render it as a grid or a vector image. And then I've done another repo that's based on top of that called Vista Manifest, and this is actually an open source website that's a collection of examples rendering. So you can download this website and install it in your own environment and run the examples. And I've got the link there where these repos can be found. But I'm not saying I've got the solution. My JavaScript programming is not perfect. I just want to plant the seed there that our prior assumptions might want to be questioned, and there may be other ways going forward may exist. So getting involved, what can you do? I've broken this into 2 areas. So for researchers, custodians, publishers and admins, and for GIS technologists. So for researchers, custodians, publishers and admins, please make your NetCDF data sets available with open data, NetCDF version 3, and that's delivery only. You don't need to store it in that format. I'll get onto that a bit later. In climate and forecast conventions, you want to check your services are functioning. You want to have it so that there's going to be scalable delivery. So you want to break up your components that you're going to be serving. And you want to have some sort of logical, common sense file structure, because these file structures can be navigated client side. And please include course headers so that they can be consumed in third-party contexts. So open data. You really want to democratize your data. If it's truly open data, you shouldn't have any user or API authentication. And you should have your data out there. Don't obscure it or obfuscate it or limit access to it. NetCDF version 3. This is needed for the work I've done because I'm using another library that does the actual reading of the NetCDF. Then I've built a renderer on top of that. That reader only works with NetCDF version 3, which is an older version. You don't need to deliver your files in that format. You don't need to store your files in that format. You just need to be able to deliver them in that format, because most THREDDS subsetting service can deliver this classic format. So CF conventions, NetCDF in climate and forecast conventions. Again, this eases programmatic extraction, and it defines the spatial and temporal access and their units. And it really satisfies the minimum requirements for 2D rendering. So I'm not trying to make an arbitrary NetCDF renderer. This is specifically suited for CF convention NetCDF files. So you want to check your services are functioning. All your parameters, you want to make sure they're supported. The horizontal stride parameters supported. Your bounding box parameters are supported. All these are needed to deliver scalable delivery of your data. And continuing on scalable delivery, you really want to aim for 1 to 2 megabytes maximum size that can be delivered. So your files can be bigger than that. They just got to be able to be delivered in that way. So the subsetting service or OpenDAP can do that. They can do that slice and dice. And please don't store on your THREDDS servers files that aren't grid files or related to the data set. Some like zip files and things like this, they can't be easily processed in JavaScript, and they're also not scalable. You want some sort of logical common sense file structure, and some conventions exist, and this is to minimize file name pattern matching and file name heuristics. So you don't want to have to you want to be able to navigate the file system using your client front end. So you just want some common sense file structure there. And CORS headers. So again, you want to democratize your data, and CORS headers are really needed for true web client consumption. So not all of the THREDDS servers out there have CORS headers. So in some of my examples, I've had to implement proxies, and I'll show some of those. But really, whether it's THREDDS or HTTP, you should have CORS headers on those. Okay, so for GIS technologists, what can you do? So my renderer needs NetCDF in CF convention. Maybe you want to make a renderer more generic, maybe supporting some unstructured data. My renderer also needs, like I mentioned before, version 3 format, and that's because I'm using this NetCDF.js library. If you're inclined, we want to look at using later versions of NetCDF. Maybe we want a 3D solution, maybe we want a leaflet plugin. So now, I know I've sort of rushed through that, but I'm going to try to bring up some demonstrations, and hopefully they'll work. If they don't work, I'll fall back to some recordings. So I'll just go through. That's my repo there. This CF render repo is the renderer. It's a JavaScript renderer, and the README basically forms the reference documentation. This repo here, this Vista manifest, is the demonstration website that's based on that renderer. So you can download and run this on your own web server. All it needs is PHP to run that. Just the PHP does minimal assembly, and it does some proxying. Here I've got an example of a THREDDS server. So this is an NCI THREDDS server. So this is what we're talking to. And over here is that demonstration website that I've got running on my own domain. Now those listed there are various providers of THREDDS services, and I've got some sample visualizations based on those. Now, as part of this demo, just try to absorb the whole thing that's going on, because these resources are in different parts of the world. I am proxying some stuff through Australia, so the response times aren't going to be fantastic, but there's a lot going on. And I don't have any formal association with these providers, but I have presented some material at the NCI, the National Computing Infrastructure in Australia, and they have kindly, they're upgrading their THREDDS server this week, so if their examples don't work, I can flip back to another one that they provided. And also, I want to give a shout out to someone here at AUT, because this website was being blacklisted on the FOSS4G Wi-Fi yesterday, and someone sorted it out last night and sent me gave me a phone call very late last night. So thanks to someone here at the university. So I'll just go through some examples here. So this is the Bureau of Meteorology in Australia. So this is looking at daily rainfall data, and there's nothing come up immediately because it's live data. It hasn't hit the server yet, so we'll pick up yesterday. So that's an example of rendering NetCDF directly in the browser with JavaScript. And if you look at that, as I zoom in, it refines, so the horizontal stride refines that resolution. That resolution improves as we zoom in. And you can see those response times for a bounding box query. If that was a WMS, you probably wouldn't get those sort of response times. And the data's in the browser, so you click on those, you've got those values. You've also got the metadata that's part of that response. So that's a basic rainfall example. So then I'll just go to the NCI, show another example here. Now, the NCI is one of the examples that have CORS headers. So these examples, I'll look at this elevation one to start with. So these examples are just JavaScript and HTML directly having a conversation with a THREDDS server. There's no back-end processing, there's no pipeline here. Well, that one took a little bit longer to load. So there's some survey elevation data. Again, you click on those, you've got the values, and if I drag that down, you can see it's a bounding box type query. So then I'll just, I'll look at a more complicated example here. So this is a forecast wind speed example. Now, while that throttle was spinning, it was downloading the data. While that progress bar is going, that's rendering the data in the browser. So this computer's 5 years old, so the rendering is a little bit slow, but if I just zoom, I'll do something here. So while that's throbber spinning, it's downloading the data. Oh, that's taking a bit longer. Just there, well, it is a live demo. Okay, that one took a bit longer, which is a bit unusual. Yeah. Okay, it is taking, well, while that throbber is spinning, it's downloading that data and it's downloading 24 time slices. So there'd be at least, if that was tiles, there'd be at least 9 tiles there over 24 time slices. So that's downloading the equivalent of 200 tiles while that throbber was spinning. And we'll just go to some other examples. Oh yeah, I'll show a wind visualization. So they were grid-based visualizations, but you can also have vector-type data in the NetCDF. This one's loading a bit slower. This one's coming from the US, NOAA. So this is an example of a wind visualization. So if I zoom in there, we'll just go into here. Again, while that throbber is spinning, that's when it's fetching the data. So that's an example of both a grid underneath and a vector. Again, the gridded image as a vector image. And then I'll just finish off with a couple of UCAR examples. UCAR are actually the authors of the THREDDS server. I'll show another animated one here. This is forecast rainfall in America. You see the way it's zooming to the countries. That's because the metadata is available for the spatial extent of the THREDDS servers. So that's forecast rainfall. What sort of motivated me to do some of this work was rain radar. I really wanted to do a rain radar example in Australia, but Australia don't publish, the Bureau of Meteorology don't publish that data right now. So I found one in America, and that's where it's raining in America right now. I could have animated this example because these data points are coming in every 5 minutes. So these grid data sets are coming in every 5 minutes, and I'll just, go back to there. So that 12:15 is the timestamp of the data set, and right now it's 12:18. So this data set is only 3 minutes old. So it might take a little bit slower to load that one, a little bit slower, but that's querying more or less live data or near live data. So you've got to think, if you're building a tile set, could you do that in a 5-minute window? These are the sort of things that we're, want to question, that there might be other alternatives out there. So most of my examples work, so I think I'm ready to finish up there. Yeah, so thank you very much. Yeah.
Thank you. Do we have any questions?
Thanks, Harris. It was a great talk. My own, from Australia, of course, and with the bomb and their precedents about radar data. That's very interesting. Just a quick one. Do you envision any sort of support for UGrid datasets in this sort of visualization work?
To be honest, I haven't looked at that, but that would require probably significant refactoring of the code because I do base it on the CF conventions because I am looking up units and so forth. So it is an important thing that my renderer works with CF convention, but this is just simply JavaScript. So like if there was another set of conventions that could be followed in terms of extracting the data and rendering it, that would be entirely possible. But what I'll just say, these examples, because you mentioned the bomb, I'll just sort of put out there that this is open data example. So that is sort of a premise of this work because the data is in the browser. So this is that is a bit of a premise to some of this work, yeah. So, thanks.
Hi, thank you for your talk. And I'm going to ask another question to which the answer is probably, again, this would be a huge refactoring of the code. But have you thought about supporting the ZAR format instead? Because I believe most of the points you made about accessing quickly NetCDF would still hold. I'm not exactly sure about the horizontal stride, but I see that as something that several organizations are starting to move towards while they were for earlier using NetCDF.
Yeah, so I'll say I don't know a lot about SAR, but I understand the basic concepts of it. But what I would just, the argument I will put forward, THREDDS has been around for 20 years. This work I actually did 3 years ago, and I sat on it. I thought, someone's got to be doing this. So I thought, well, no one is, so I'll put it out there. Because this has been sitting in front of us for 20 years. But in that 20 years, our devices and our networks have improved. So these alternatives could be considered. So SARS that's later in the game, but this has actually been in front of us for all this time. With these examples, the data is larger and the processing on the client is higher. So maybe that wouldn't have been a useful solution 20 years ago, but it has been in front of us. So I think now, 20 years down the track from Slippy Maps, I think there's multiple options to work forward. So this just might be one option. There could be other ways to go. But with ZAR, what's the data based on? Is that still coming down to live data? You don't want it based on some sort of denormalized massive file or something like that. So yeah, I think nowadays there's multiple options to do this.
Thank you.
Do we have any more questions? No, okay, let's give Harrison a huge round of applause.
Thank you.